Hi team, in this video I describe what the Jacobian is and work through a couple examples. Let's get started. Okay, so what is the Jacobian? Well, the Jacobian is a multidimensional form of the derivative. So let's say we have 6 functions, each of which is a function of 6 independent variables. So for example, we have y1 through y6 being equal to function 1 through function 6 being dependent on the variables x1 through x6. We could use our vector notation to write these equations as capital Y being equal to capital F of capital X. Now, if we want to calculate the differentials of y as a function of the differentials of x, then we can write them out as being the differential y1 being equal to the partial derivative of f1 times the differential dx1 plus, and then carrying on for each of the partial derivatives times the corresponding differential. Now we could also write this using our vector notation, and so on the left we've got a vector of all of the differentials of y being equal to the partial derivatives of x with respect to their corresponding independent variable times a vector of all of the corresponding differentials. So this 6x6 matrix of partial derivatives f x of x is called the Jacobian, which is annotated using the letter J. Okay, let's look at an example. Let's say we have a function x being equal to L1 cosine theta 1 plus L2 cosine theta 1 plus theta 2. And we have another function named y being equal to L1 times sine theta 1 plus L2 sine theta 1 plus theta 2. So what we want to do is figure out the differentials of x and y. So we could write that out. So the differential x is going to be equal to the partial derivative of x with respect to theta 1 times the differential theta 1 plus the partial derivative of x with respect to theta 2 times the differential theta 2. So let's write that out. So the derivative of L1 cosine theta 1 is going to be minus L1 sine theta 1. And then the L2 cosine term, this is going to become minus L2 sine theta 1 plus theta 2. And that's all times the differential of theta 1. And we're going to add to that then the partial derivative of the equation with respect to theta 2. So the L1 cosine theta 1, that's a constant, the derivative of that becomes 0. And this last term then becomes minus L2 sine theta 1 plus theta 2 times the differential of theta 2. So that becomes minus L2 sine theta 1 plus theta 2 times the differential d theta 2. So now if we want to work out what the differential of y is, then we differentiate this equation with respect to theta 1, and that result is all times the differential theta 1, and then we differentiate it with respect to theta 2, and that result will be all times the differential theta 2 added together. That gives us our result. So let's look at writing that out. So we've got the differential of y being equal to the derivative of L1 sine theta, which is going to give us L1 cosine theta 1, plus the derivative of L2 sine theta 1 plus theta 2. So that's going to be plus L2 cosine theta 1 plus theta 2. And that's all times the differential of theta 1. We're going to add to that then the derivative of this with respect to theta 2. So this part here is a constant, so that disappears. And then we're left with this L2 sine term, and that becomes L2 cosine theta 1 plus theta 2. So the results of that L2 cosine theta 1 plus theta 2 is all times the differential of theta 2. So here we've got the differentials of as a function of the partial derivatives and the corresponding differentials. So we can now take this and write it in a vector form. So we could write it as x, dx, and dy being equal to, and then a 2 by 2 matrix. So we have all of our d theta 1 terms written here. So we got minus L1 sine theta 1 minus L2 sine theta 1 plus theta 2, then minus L2 sine theta 1 plus theta 2, and it's going to be all times the differentials of d theta 1 and d theta 2. And our second row then becomes L1 cosine theta 1 plus L2 cosine theta 1 plus theta 2, and then L2 cosine theta 1 plus theta 2. So this 2 by 2 matrix that we have at the end here, well, this matrix is the Jacobian. So in this video, I've described what the Jacobian is and worked through a couple examples. I hope you found this video helpful. Thanks for watching.